Hello students, we are going to discuss about the historical experiment of Rutherford, in which he concluded that the 99.99% mass of an atom is concentrated in its center, which is called nucleus. So this experiment was performed by Rutherford in 1911 with the help of alpha particles. He allowed to fall alpha particle beam on a gold foil, and he observed the scattered alpha particles at different angles. And from the observation, he concluded that whole mass of the atom is concentrated in its center, which is termed as nucleus. So approximately 99.99% mass of an atom is concentrated in the center of the atom. Then he named that center as nucleus of the atom. Thus Rutherford discovered the nucleus. That is why he is named as father of nuclear physics. Now we focus on the topic of our syllabus of B.Sc 1, that is Rutherford alpha particle scattering experiment. So in Rutherford alpha particle scattering experiment, we have to derive the expression for cross-section. What is cross-section? So cross-section is nothing but the area, and in this case it defines the collision of alpha particle with the nucleus of gold. So what is the cross-section? It is defined and termed by symbol sigma. It is the probability of collision, that is interaction. So for scattering, it is defined as the ratio. It is defined as the ratio of the number of scattered particles to the total number of incident particles. So scattering of particles is of two types: vis elastic and inelastic. So thus the cross section is also of two types, that is elastic collision. For elastic collision, the cross section is sigma E, and for inelastic it is termed as sigma I. So important topic that is in our syllabus, that is differential scattering cross section. So what is differential scattering cross section? So if incident particle of mass m1 moving with velocity u1 strike the second particle of mass m2, that is nucleus of gold, and this is gold foil, then when it is supposed that it is at rest, then u2 is equal to 0, and the incident particle strike this particle and collide it with it. As a result, it deflected and scattered in a certain direction. So there are two systems to study this type of interaction. One is lab system, and second is center of mass system that we have already studied. So the parameter or the topic of interest in the alpha particle scattering experiment is the differential scattering cross section. So differential scattering cross section is scattering cross section in a given direction with respect to incident particle's velocity. Given direction with respect to incident particle velocity is termed as differential scattering cross section. Differential scattering cross section. So D.Sc. So in this case, suppose this angle is solid angle is d omega. So then the number of the particle that is scattered into this direction, total number of alpha particles scattered into this direction divided by number of particles which are incident in this direction is the ratio. That ratio is called D.Sc. So this ratio defines the probability of scattering of the alpha particle in this particular direction. That is why it is called differential scattering cross section. Differential means part of the total cross section. And so this parameter is important in case of Rutherford alpha particle scattering experiment. Incident particle of mass m1, velocity u1, moving towards the target which is at rest and having mass m2, and this collision occurs, and after collision the incident particle move in this direction, that is scattered in this direction. So this angle is called angle of scattering in lab system, and the target start moving in this direction, and this angle is called alpha, which is called angle of recoil. So if the collision is elastic, perfectly elastic, in this case this angle is 90 degree, that is alpha plus phi is equal to 90 degree. So in the special case, if the two particles are of equal mass, then in this case this velocity v1 is equal to u1 cos phi, and this velocity v2, that is u1 sin phi. So this expression we have already derived. Now focus on the today's topic, that is the relationship between angle of scattering in lab system and angle of scattering in center of mass system. So the relationship between these two can be derived using this expression. So this is a center of mass system. Center of mass system, center of mass is supposed to be at rest, and both particles are moving toward each other. And in case of center of mass system, we change this figure into this form. So this is center of mass, and after collision, this center of mass before collision and after collision remains at rest. So we treat the origin at the center of mass, and both the particles start moving. This m2 is moving towards center of mass, m1 is moving towards center of mass, and after colliding they move in this way. So after colliding they move in this way. So this angle is called angle of scattering in center of mass system. And what about angle of scattering in a lab system? That we have already discussed. So this is the lab system. So in lab system, center of mass, this target is at rest. Incident particle is moving toward this particle, and as a result center of mass is also moving in this direction. And after collision, the direction of center of mass remains the same, and this is the direction of scattered particle, and this is the direction of recoil target. So this figure is easy to understand or to visualize the scattering experiment, but center of mass system is helpful in driving the mathematical expression of this scattering experiment. So this is the need why we change lab system into center of mass system. The actual experiment of collision or we call scattering, the actual experiment of collision or the scattering of alpha particles are performed in lab system, but description of the experiment becomes much simpler or easy in the center of mass system. So note that both systems are inertial systems. That means that you know what are inertial system. That's all the laws of physics are applicable in these systems. Now, today's topic is the relationship between the angle of scattering in lab system and angle of scattering in center of mass system. So the expression between the relationship between them is very easy to remember. So tan of phi is equal to tan of theta. You can remember tan of phi. Phi is angle of scattering in lab system, and theta is angle of scattering in center of mass system. So tan phi is equal to tan theta. Tan theta is sin theta upon cos theta, but plus this term, that's m1 upon m2. M1 or m2 is the mass of the incident particle and the recoil or the target. Okay, the special case. So there are three special cases. First is if m1 is greater than m2. Second is if m1 is equal to m2, and third is if m1 is less than m2. So three cases are there. So first, m1 is greater than m2. So in this case, this term is greater than 1. So this term is greater than 1. If this term is greater than 1, then tan phi is always less than 1. Okay, and if tan phi is less than 1, so there will be two values of theta for one value of phi. Okay, in case of m1 is equal to m2, m1 upon m2 is equal to 1. In this case, cos theta plus 1. So as a result, tan phi is equal to tan theta by 2. Thus, the relationship between angle of scatterings in lab system and center of mass system is represented by this expression, that is angle of scattering in lab system is equal to half the angle of scattering in a center of mass system. And the third case, when m1 is less than m2, that is m1 upon m2 is less than 1, in this case we call tan phi is nearly equal to tan theta. So for alpha particle scattering experiment, in this case is applicable because mass of the alpha particle is less than mass of the atom, mass of the nucleus of gold atom. So this is in this case both these angles, angle of scattering in lab system is equal to angle of scattering in center of mass system. So now geometrical relation between phi and theta. So that is phi is angle of scattering in lab system, theta is angle of scattering in center of mass system. So we can derive this expression, that is v1 vector is equal to v1 dash vector plus v vector. So what is this? Where v1 dash vector represents the velocity of scattered particle in center of mass, frame of reference or center of mass system. So what is a scattered particle? That is alpha particle. So alpha particles velocity in center of mass system. And what is v1 vector? Velocity of that particle, that is scattered particle in lab frame. So this is in lab system, this is in center of mass system. Velocity of the same particle measured in lab system and center of mass system. So where capital V is the velocity of center of mass in lab system. So capital V is the velocity of that we have discussed in our previous lecture, that is m1 velocity of incident particle. This is the velocity of center of mass. v1, v2 are the velocity of the particles in the after collision in center of mass system. In lab system. So in center of mass system, so we define it as v1 dash, v2 dash. So v1 dash, we are focusing on this velocity, that is velocity of scattered particle. So v1 dash, velocity of the scattered particle in center of mass system. Okay, so I think you remember this expression, that is v1 vector is equal to v1 dash plus v. So using this mathematical expression, we can trace a graph or a figure. So suppose this is a circle and O represents the center of this circle. So O represents the center of this circle, and this center is nothing but the origin of center of mass. O is the origin of center of mass. I repeat, O, center of this circle, represents the origin of center of mass system. Okay. Now, this velocity v1 dash vector, what is this? Velocity of scattered particle in center of mass. And similarly, v1 is the velocity of scattered particle in lab system. So O dash is the origin of lab system. O dash is origin of lab system. Therefore, O dash O represents the velocity of center of mass. So O dash O represents capital V. So this is a capital V, and this velocity of scattered particle in lab system is represented by this vector, that is O dash Q. So O dash Q vector is velocity of scattered particle in lab system. OQ vector is the velocity of scattered particle in center of mass system, and O dash O vector represents the velocity of center of mass in lab system. Center of mass in lab system. Okay. So again focus on this figure. So from this figure it is clear there are two angles. This angle is in lab system, angle of scattering. This angle is in center of mass system. So this is the graphical relationship between phi and theta. So this is all about. Now we discuss only the special cases. So description of this figure is written here. Thus head means the vector representation. Thus head of velocity vector of all the scattered particles will lie on the circle of radius OQ, okay, and whose center is at O. O is the center of the circle as well as the origin of the center. Now special case. Special cases, there are three special cases. So it is very clear if V is less than V1 dash vector, V is the velocity of center of mass in lab system, and V1 dash is the velocity of scattered particle in center of mass system. Okay, so V is the velocity of center of mass in the lab system. V1 dash is the velocity of a scattered particle in center of mass system. In this case, if it is less than 1, so this is the case, this figure represents the case. So it is V is less than V1 dash magnitude. So for single value of phi, there is only one value of theta. So in this case, for one value of phi, that is angle of scattering in lab system, there is only single value of theta, that is scattering angle, or angle of scattering in center of mass system. But if second special case, if V magnitude is equal to V1 dash magnitude, so in this case this O dash must be lie on the, so in this case O dash is lie on the circumference of this circle, then O dash O is equal to OQ. So this is the radius of this circle. So in this case both magnitude of this velocity and this velocity are equal. So in this case, again for one value of phi there is single value of theta, but in this case phi can vary from 0 to 90. How? So suppose this Q is here, in this case angle phi is 0, and if in this case this is phi is going to increase, and the particle moving from this point to this point, in this case, and when Q coincide with O dash, the angle becomes 90. Okay, and but for the same case, theta can vary from 0 to 90 here, and when Q point reaches at O dash, theta becomes 180. So theta can vary from 0 to 180, and phi can vary from 0 to 90 only. So this special case indicates that. So it is written, now the point O dash lies on the circle. This is the figure. So point O dash lies on the circle. Circle means circumference of the circle. So in this case, the value of phi changes from 0 to 90 degree, and but theta will vary or change from 0 to 180 degree. So this is the second special case. And about the third special case, when V greater than v1 dash, then the radius vector v1 dash of the circle is less than v vector magnitude, and hence the point O dash lies outside the circle as shown in this figure. So thus, in this, so focus on this figure, and this figure describes the this special case. This is again origin of the center of mass system, and this is OQ V1 dash. And if V magnitude is greater than this, then it should be O dash should be outside this circle, and this is the radius of the circle which represents the V1 dash. But it is greater than this, then it should be outside the circle. And from this circle, we can it is clearly indicated that for single value of phi is angle of scattering in lab system, there are two values of theta for which v1 dash and v1 dash are equal. This is the radius of the circle. That means the velocity of the scattered particle in center of mass system is same, but for two angle of scatterings. So this angle theta f is angle of scattering in the forward direction, and theta b is angle of scattering in the backward direction. So theta f and theta b are two angle of scattering in center of mass system. So this case, there are two values of theta for single value of phi. So for which velocity of scattered particle remains the same. Two value of thetas for single value of phi, for which velocity of scattered particles remains the same. So from this figure, it is clear from the triangle law of vector addition that is O dash P is the resultant vector, because these two vectors O dash O and O P vector are in the same direction. This is the head of this vector, and this vector is in the opposite direction. So according to triangle law of vector addition, so in this triangle, so according to triangle law of vector addition, so using triangle law of vector addition, O dash P vector is equal to O dash O vector plus OP vector. So therefore V1 B vector is equal to V vector plus V1 dash vector. So where V1 B vector is the velocity of the scattered particle in the backward direction. This is the velocity. So magnitude of this velocity can be calculated from this vector addition, that is V square V1 dash square plus 2 V into V1 dash cos of this angle theta B under root. So similarly, V1F is equal to V vector plus V1 dash vector. So this theta F is the angle of scattering in the forward direction. So magnitude can be calculated for the two velocities. There is a particular value of scattering angle in lab system at which there are only one value of V1 dash, one value of V1 dash, that is V1B must be equal to V1F. So this value can be guessed from this figure. So if we come close this O dash to O, and the particular case arises in which O dash O vector length is equal to OQ, that is O dash O is equal to OQ. What is O dash O? O dash O is the velocity, capital V, velocity of center of mass in lab system. OQ vector is V1 dash vector, velocity of scattered particle in center of mass system. So that means velocity magnitude of center of mass in the lab system and velocity magnitude of scattered particle in center of mass system are equal. This is, and that particular angle is angle of scattering in a lab system is represented by phi s. So this is all about geometrical representation or geometrical relationship between phi and theta. Both are angle of scatterings. Phi is the angle of scattering in lab system, theta angle of scattering in center of mass systems.